Hello everyone. In this video, we are just going to discuss deeply about the build system in ESP IDF for ESP32 SoCs. So what is this build system gonna do for us? On the screen, you can see the basic project of IDF systems. That is, it contains various components from ESP system, main components which the user develops for the application of the user depending on their use, and the third-party libraries and extended libraries from manager components. And all these components clubbed together forms the IDF project. And this is the basic overview block diagram of the IDF project. And what this build system does is, primarily the build system compiles all the components available in the IDF project, handles compile time configuration based on kconfig file, and we will discuss about the kconfig file later in this same video, and generates partition table, linker scripts, bootloader, file system images once it is compiled, and it provides integration to various tools such as configuration tools, flashing tools, serial monitor of the IDE, and it provides the integration with ESP component registry, which will be most widely useful for using almost all the libraries in ESP IDF. These are all the basic things that the build system does for us. And this is the basic block diagram of the build system, and how do different parts of the ESP IDF build system relate with each other. ESP IDF build system is written in CMake file right over here. When you run the build system process, you typically invoke this particular CMake file. So there are two ways for invoking the CMake list file. One is using the command line interface by providing the command idf.py, and another one by using the IDE extension. That is, for example, in Expressive IDE, you can build the project by clicking on build icon or clicking on project build. That's it. And once it is built, the CMake list file executes and it generates the build script required for the project. And that particular build script is executed by the tool called Ninja. So this is the basic process of build system in ESP IDF, and later this is useful for cross compilation, and there are various other CMake list files also available for an application. ESP IDF CMake list file for all the primary ESP IDF application libraries, and further that file will be converted into bin for flashing onto the ESP32 SoC. So this is the basic process of build system in ESP IDF. Let's create a basic project using ESP IDF. When you type in like ESP-IDF, you will get this command line interface. While installing the ESP IDF and Expressive IDE, this also gets installed along with that. So in that particular video of downloading and installing the ESP IDF along with Expressive IDE, I have taught you how to install this particular thing in your PC. Just open this command line interface. Once opened, I am just going to move to my C repository, that is C drive. Here I am just going to create a folder called SM Academy Test. So I am just going to move back to C drive, cd dot dot cd dot dot cd dot dot, and here I am just going to move to cd space SM Academy Test, so that the path is set to that particular directory which I have created right over here. Now here, for creating an empty project, you can give the command idf.py space create hyphen project, the app name or the project name. So the project name that I'm going to give is project 1. When you give this particular command, the fresh or new project will be created in ESP IDF. You can see the project was created in so and so directory with the name project 1. So here you can give whatever name you want for your project, and when I open this directory, you can see the project has been created. It contains main folder. Inside the main folder we have the CMake list file and the project main source file, and outside the project directory also we have one more CMake list file. This is the project CMake list file, and inside the main we have the main CMake list file. And for each and every component that you are creating for this particular project, you will be having the CMake list file generated. So this is the pattern. Just remember about the pattern of executing this. This will actually execute the CMake list file, which will generate the build script, and this build script will be executed by the tool called Ninja in ESP IDF. So this is the general pattern for each and every component, whether it is a main component or a user specific component. You will be having a CMake list file, and the number of source file and header file is dependent on the user application or the external library component or the ESP IDF library component. So whatever it may be, it will be containing a source files, CMake list file, and number of header files included in the project. And inside the source file you can see we have an empty main function and the stdio.h included. Now for building this empty project, you can give idf.py space build. Let's build and see how the build works in this particular basic project created. Now the application is being built. Let's wait for a while. Sorry, before that you just want to move to project 1 directory, since the project is available inside the sm_academy test and inside the project 1 folder. Move inside that particular folder and now give idf.py space build. Build is taking place. Let's wait for a while to build system to complete the building process. So what this build does is it will execute the CMake files available inside the project and available inside each and every component of the project. Here we have only main component available, so this particular CMake file will be invoked in the global CMake file right over here inside the project, and this will generate the build script, and later this particular build script will be run by a tool called Ninja in ESP IDF. Finally, at the end of the process, the compiled application will be available inside the build directory right over here. You can see as soon as I gave the build command, the build directory has been created inside the project and all the other files are generated inside this particular build directory. So the build is complete and I am moving inside the project folder, and you can see here a build directory is created. I am just moving inside the build directory right over here, and you can see these are all the files generated. We have a CMake list folder which contains all the CMake files, and build folder is created, and you can see inside the build folder, inside the config folder, here is the SDK.h file generated, which is useful C code which can be taken in the compile time configurations. So this is the main important configuration file which is generated in the build process. And inside the bootloader directory, we have all the bootloader related files, and partition tables of all these will be flashed onto the ESP32 SoC. So this is the major thing, and this particular bin file generated, that is bin type file generated, will be flashed onto the ESP SoC. So this is the flashing software which can be used, and this ELF file right over here is useful for debugging purpose, and the map file right over here is useful for analyzing the size layout of the program that is created by using the command idf.py size in the command line interface. Compile commands JSON file available right over here is used by the IDE to provide the code navigation in various IDEs such as Visual Studio or a specific IDE. Whatever the IDE that you are using, this compile commands.json is useful for providing the code navigation in IDEs. And we have another project description.json file right over here, which is mainly an ESP IDF specific file and way for build systems to communicate info about the project to IDEs and command line tools. So this is the particular file which provides the info to the IDEs about the project, to the IDEs, and also to the command line tools. And we have flasher related files such as these flash arcs and flash project arcs, which contains esp-tool.py info to flash the program onto the ESP32 SoC. And also it is used by the tools such as idf.py flash in the command line interface for flashing the software onto the ESP32 SoC. And these are all the various files generated in build folder. Let's move to the presentation part. In addition to the build directory, there is SDKConfig file which stores the compile time configuration, compile time project configurations, and it can be modified manually or using any GUI, and it can be also tracked in the Git. Before extending our project or adding more new components to our project that is created, that is to the basic project created, we will talk about the configuration system in ESP IDF. Each component defines its config in kconfig file in the configuration system, which is designed to create SDK.h or SDK.CMake list file. So the main motto of the configuration system, kconfiguration system, is to create an SDKConfig.h and SDKConfig CMake list file, which has a set of compile time configurations which can be used in C code and also in CMake list code. So in C code or C source file, you can use this SDKConfig.h created, and in the CMake list file, you can use this particular generated SDKConfig.CMakeList.txt file. And source is the SDKConfig right over here. The source for creating these two files is from this SDKConfig file, and as I said, you can manually edit this particular SDKConfig, or using any GUI also you can edit this particular SDKConfig file, and the kconfig file will help you to generate these two things from the source of SDKConfig. The configuration system reads all the information about the configuration options from kconfig file. It gets the default values from the SDKConfig defaults. If it exists, or the kconfig itself generates initial version of the kconfig.h and CMake list file. When you edit the SDKConfig manually or using GUI, it will be modified and the output files will be regenerated. So each and every time when you edit this particular SDKConfig right over here, the SDKConfig.h and SDKConfig.CMake list file will be regenerated each and every time. So that's all about the configuration system that I want to talk. This is the basic configuration system, that is the compile time configuration that performs in the build process. And the CMake list file, basically we will be doing all these things. We will be including and defining source files using srcs, or source directories can be directly included or excluded using the command src_dirs, and excluded using the command exclude_srcs. So source directories can be directly included using this particular command, excluded using this particular command, and single file can be included using srcs command. And you will be defining the include directories using include_dirs, and private directories can also be included using priv_includes_dirs. And the dependencies can be included using requires command or priv_requires command. Example, for IDF component registry you can use this particular command, and inside the bracket you can give as much as commands like this as you can for including all the files inside the CMake list file. So this is the basic structure of CMake list file available in ESP IDF. We will be defining source file, including directories, and including and defining dependencies for your project using all these commands. These are all the basic things that we will be doing in CMake list file. Now let's extend our project scope by creating more and more components, and this is the basic template that you want to follow for optimizing and using the Espressif IDE or ESP IDF project to a greater extent. So I'm just going to open the Espressif IDE, and I'm going to open the project that I have created, that is project 1 right over here. I'm moving to the folder where I have created the test project. Inside the project 1, inside sm_academy test, I'm just going to select this particular project 1 folder, and I'm going to provide launch. Now what I'm doing is I'm just opening the project that is created in Espressif IDE. If you are using a Visual Studio, you can open that. So IDE preference is based on the personal interest. So I will not interfere in that. If you are convenient with Espressif IDE, you can use it, or whatever IDE you are convenient. If you are convenient with Visual Studio, you can use that. So here in this Espressif IDE, I'm just going to click on import projects and select existing IDF project. Next, click on browse, and inside the window that is popping out, move inside the folder where you have created the project file. Inside the project folder, select it and click on select folder and click on finish. You can see the project is opened in Espressif IDE. This is how you can open the project in Espressif IDE. This is the main source file, and this is the CMake list file available inside the main source file. And inside the CMake list file available in main source file, we have included the source file project1.c, and include directories has been included right over here. And outside CMake list file contains all these things. You can see it contains it has included the project.cmake, and the project1 has been included inside the project. For adding a new component, you need not add the source files inside the main folder right over here. Instead, you can create a folder outside the main folder, that is inside this project folder. In my case, the project name is project1. So inside the project1 folder, I'm just going to create a new component, new, right click on this project1 folder and new, and select Espressif IDF component. You can give whatever name you want. I'm giving app component and click on finish. Okay, you can see new component has been created. By default, it has created app component. Inside the app component, I got a header file included and a source file included as well inside the app component folder. So this is the pattern, and also it contains a CMake list.txt file. So these are all the basic things required for a component, whether it is a user-defined component, ESP IDF component, or a third-party library. These are all the basic things required for a ESP IDF project. So this is the basic pattern followed. Just understand that. Inside the include, we have an empty include file, and inside the source file, we have an empty function created. Inside the CMake list file, you can see the app component.c source file has been included, and the include folder has been included using the command include dirs command in the CMake list file. So how many components that you want can be decided by the user itself, and the each and every components can be created like this outside the main folder inside the project folder for better visibility and for better understanding about the project. Because if you create files directly inside the main folder right over here, for now or for today, you will understand the basic process of the project that you are creating. By the time when the project develops and contains so many components, you will not even understand why you have added the components if you are watching the same project after 6 months or 1 year of time. So for better understanding and visibility of the project, this optimization can be followed. Each and every component can be created right over here using the format that I have showed just before. So I hope you learned the basics of build system, configuration system, and the process of creating the project using the command line interface, that is ESP IDF project using the command line interface, and also how you can add new components to the project that you have created for ESP IDF for ESP32 SoCs in this particular video. I hope you learned something new and understood something new in this particular video. See you in the next video. Thanks for watching.